Hello, how are you? Welcome back to Geo Cafe. I'm Teacher Jess. I hope you're well. I've got Loki joining me today. There he is in the background. Say hello. Lazy puppy. Don't know if you can see him properly. There he is, busy basking behind us. Okay. Okay. I hope everyone's been doing well. I hope everyone has their coffee. Hmm. Okay. So, what we are looking at today is a section from the matric curriculum, and we're looking at the urban heat island. Okay, let me just get the screen up so long. In essence, the urban heat island is how a developed area like an urban area can have an impact on its immediate surrounding climate, specifically or primarily looking at the heat, how it influences the temperature of that area. Now, it's considered a microclimate because it happens over a small scale. It ranges over the area of that city. But before we can really dive into understanding what the urban heat island is, I first now need to explain why it occurs. So, the idea of the urban heat island effect is that you have this central part in the middle of the urban area that tends to be quite warm or a lot warmer than the surrounding suburban or rural areas. We can maybe do another video where I explain the difference between urban and rural some other time. But in a nutshell, you can think of urban as your cities and developed areas, and your rural is more your countryside, farm side areas. And one of the definitions that I always include in these notes, it does contribute to this whole concept a lot, is albedo. So basically, that is how reflective a surface is. So when we learn about the Earth's heating or the atmosphere's heating, we look at albedo, and that tells us how much light or sunlight is reflected off of the Earth's surface and how much is used to actually warm up the Earth. So if you have a very reflective, very shiny or smooth area, usually very light in color, it will have a high albedo. So it will reflect back a lot of the light. If it has a low albedo, it will usually have a darker color. It will have a more coarse or porous surface area or texture. What are you doing? There we go. It will usually have a more coarse surface and it doesn't reflect as much light. It's basically the same reason why people maybe buy white or silver cars rather than darker cars because the light colors help keep the car cool. Oh, shame. Loki is not cool. Loki, do you want a treat? Here you go. Another thing that I didn't actually add into the notes, but another factor would be the heat capacity of different material. So where I'm going with the whole albedo and heat capacity thing is that there are different materials that make up urban areas compared to rural areas. If we think about urban areas, let's say, we have buildings, streets, skyscrapers. You can imagine the typical concrete jungle. Okay, so it's a lot of gray surfaces, dark surfaces, tar roads, that kind of stuff. So a lot of heat gets trapped in those areas. Um, the heat capacity of those materials will also play a role. So what I'm referring to with heat capacity, I'm not going to go into a whole science explanation, we're not doing physics, um, is how well a material holds onto heat or stores heat before it starts to get hot. If we take a cup of coffee as our example, if you've made yourself a cup of coffee and you leave a metal teaspoon in it and you grab that teaspoon, it's going to feel hot. but if you left a wooden teaspoon in it and you grab it, it's not really going to burn you. So that's the basic difference. Different materials get hot at a different rate. And usually we use the materials that get hot quickly, like concrete or stone or tar or steel or iron, all of those things get hot quickly. We use that when we build urban areas. Okay, we have the basics, I hope. So this is just a nice little visualization of what the urban heat island effect looks like. So basically, where you have your urban area over here, it holds onto a lot of heat. So it kind of, no, it radiates a lot of heat. That's a better way of putting it. So your surrounding rural areas tend to be a lot cooler, and your urban areas, your built up concrete jungle tends to be a lot hotter. And I found some really nice maps that actually shows this. So I was looking at how different cities prepare for different heat waves, and this was just a really nice heat map. Where is it of? Prague? Yes. And you can see the red areas, I'm assuming the red areas would be hot. It's very small, but I can see over here it says 45 degrees by the red and 35 degrees by the blue, so that being Celsius. So the red areas are hot, almost 10 degrees hotter than the blue areas. And you can see all of those areas are further inland. They've got large buildings, but they have, it looks like larger buildings. It's very built up. Where it's green or blue, it looks like there are dams or fields, this being the river. So you can see quite clearly where it's hot and where it's cooler. Where it's cooler, you have your natural vegetation, you have bodies of water, and where it's a lot hotter, you've got your cities and your big buildings. I don't know how accurate this map is, but I love how it depicts this island that we're talking about. So you have this hot island over here being surrounded by cooler areas. So that is your urban heat island. Let's just take a look at the profiles during the day and during the night, just so we understand how the climate changes within those 24 hours. So it's not always just typically hot, it does vary slightly. So during the day, we have hot air rising above the city. We know that hot air rises. And the cool air moves in from the surrounding suburbs or rural areas. I think I did see a nice side view of this somewhere. Oh, sorry, it's literally on the next slide. There it is. There's the nice side view. Okay, so we have the hot air rising, and we have some cool air coming in from the sides, from the rural areas coming towards the middle. Hopefully some of my students would be able to recognize that that is forming a low pressure system over here. The hot rising air lifts the air off the ground. That forms a low pressure system, and that is why the cool air blows towards the low pressure. Warmer air over the city rises, so the heat island mushrooms over the city. The heat island encloses the built up area and is less concentrated during the day. So we can see that as it comes inland, it comes into contact with all of these materials that I was saying can reflect and radiate this heat, this terrestrial heat, and that will warm up the air, causing it to rise. But because it has this constant circulation, it has this constant rising air, more cool air coming in, it actually reduces the intensity of the heat island effect. Okay, during the night. So now during the night, you don't have as much heating in the surrounding area, which means that the urban area will lose heat a lot quicker. So you don't have as much heating overall, so your net heat is exiting. Things are getting very cool. The city cools at night, therefore upward currents are not as strong. So we don't have that same, let me go back to the previous, no, we don't have this. We don't have that heating of the ground, all of that air rising up. So we don't have those strong lifting currents. And without those strong lifting currents, we also don't have the air whooshing in from the sides. And what that means is that it kind of sits and makes like this dome over the city. The heat island becomes shallower and forms a dense layer. So this is what we're describing. So you can see it's still warmer, but you don't have that intense heating. Hey, welcome. I see it's your first time here. I saw you joined me or you were on one of my last YouTube videos. It's so nice to see you joining me here as well. Okay. I think what I was saying was that it doesn't get as hot, it doesn't rise as quickly, and because it doesn't rise as quickly, it doesn't rise as high. Loki, what you doing? What are you up to? You leaving? Hi. I think he's leaving. Say bye, Loki. Okay. And what that means is that even though we have this dome, this little heat island, it doesn't reach as high up into the atmosphere. And you don't have that same pulling effect from the surrounding cool air. Pollution is more concentrated at night, causing a pollution dome. This movement of air helps circulate fresh air. I'm saying fresh air with the question mark, fresh air from your surrounding rural areas, and it reduces the concentration of pollution in the city during the daytime. But at night, where you have this little bit of the heat island effect, where you have maybe some sinking air pushing down against it, keeping it in place, you have a pollution dome. And because you have this difference in density and the difference in movement, your pollution gets trapped within the dome. So that's kind of what it would look like. You can almost see that dome shape. So you get this layer of pollutants, of air pollutants that get stuck against the urban area, or basically against the ground. Pollution domes are dome-shaped masses of polluted air above the city. Causes of pollution domes. So pollutants is any kind of substance in the atmosphere that isn't naturally there or might disturb the environment or some other way. So main sources of pollutants is anything from your industrial processes, anything from transport. So we've got your carbon monoxide, nitrous oxide, fossil fuels, sulfur dioxide, the whole works. So transport, industries, pretty much just our day-to-day routine would produce some or other type of pollutant or air pollutant that would then get caught in the atmosphere just above the urban areas. The urban heat island effect causes a temperature inversion, which means the pollutants are trapped in the inversion and cannot be carried away. I don't know if we're going to be able to go into temperature inversions. Let me see if I can just give you a basic explanation of what that means. In normal atmospheric conditions, you have warm air closer to the ground, and as you go up, it gets cooler and cooler. With a temperature inversion, basically it switches the order. You have cooler air closer to the ground, and then you have this warm air above it before you have cold air. So it's kind of like a sandwich, cold, warm, cold sandwich. And this difference in density means that things like smog or normal circulation can't really move through that inversion layer, and it gets trapped over here. So it gets trapped as if it was some type of a physical barrier or this invisible ceiling, And smog or smoke or any type of pollutants, they can't get through that inversion layer. All right, smog, I've now used that term, but smog is basically a combination of smoke and fog. We use it quite generally when we're talking about pollutants or air pollution. So because of this inversion layers, I think you can see it here, kind of, yes, there and a bit over here. So there's the cool air, there's the warm air, and there's the, it's supposed to say sinking warm air. Well, it would be cooler because it's higher up. So because we have that cool and then warm and then cool again, it's a temperature inversion. And same thing over here. Warm over there, cooler over here, temperature inversion. Just a nice little visual of what smog would look like, or what a pollution dome would look like. So this all gets stuck over the urban area, over the city, and you would need some or other wind to come and blow it away. Quite a few effects that it has. First one, it always hits home, is health problems. So we always take something seriously if it can affect our health, and all of the air pollutants that we are stuck living inside of can cause all kinds of respiratory problems, so lung problems, asthma attacks, lung infections. Hello, I see it's your first time here. Welcome. So any kind of breathing problems because of the pollutants, the harmful pollutants that we are inhaling. So acid rain, certain types of pollutants would dissolve in the water, in the atmosphere, and when it falls, when it rains, it's slightly acidic or fairly acidic actually, and it can cause damage to buildings and plants. You might think plants isn't a major concern until you realize that that does include crop and our food. Okay, insulation is reduced and the sun's rays cannot penetrate through the pollution, so we don't get the same amount of sunlight as we normally do. So if you look over here, I have no idea what kind of weather this is. So it could be a nice sunny day out, but they are not enjoying it. And believe it or not, we do need sufficient sunlight to live as happy, healthy human beings. And then air pollutants and greenhouse gases would contribute to climate change as well. So that would be its own different discussion. But at the end of the day, pollutants are harmful to our environment in a bigger scheme as well, not just to our immediate health or our day-to-day lives. So there are two main things that we can do, or that city planners can do, to try and reduce the urban heat island effect. And that basically comes down to making surfaces lighter and greening. So making surfaces lighter is quite straightforward. It could be anything from repainting things to using different types of materials when we construct things. So the reason why you want to make surfaces lighter, remember in the beginning I spoke about the albedo. To make surfaces lighter, it means that more light would be reflected away and less would be kept to heat up the urban area. Okay, so dark surfaces absorb more heat than light surfaces. Heat absorbed by dark surfaces can transfer into buildings, meaning energy is used by air conditioners to cool down. And that eventually just has a negative feedback effect. We use more electricity, more energy to run the air cons, and that just contributes more to the pollutants, and it cycles back endlessly. So if you actually have a cooler building, the same reason why I said people tend to buy light colored cars like silver or white, it's cooler. You don't have to run as much petrol or electricity to keep it cool. Lighter, more reflective surfaces reflect the heat and stay cooler. Buildings can be painted by light colors. So instead of reinventing the wheel, instead of reconstructing entire cities, we don't have to demolish what's already there. We can just do very easy substitutions. We can just paint over surfaces again, or just use lighter mixture materials in the future. And then greening. I know greening is a nice little buzzword for many urban planners. So greening basically means that you have more vegetation in the city. So having maybe rooftop gardens or more trees built into the surrounding landscape somehow. I've gotten a few cool pictures of some proposals I'll show you in a minute. So it can reduce energy costs. That sounds like a win-win. It blocks out the direct sunlight from actually reaching the buildings, and rooftop gardens can be a nice breakaway for the people in the building themselves. So it looks like a lovely place to go up for a lunch break or to go shout into the abyss when you've had an unpleasant meeting, whatever it may be. So I see lots of upsides in that. Another part of the greening vision is not just having more vegetation, but creating something that they refer to as green corridors. I think it's green corridors. You can kind of see it. So basically, you have this pathway of greenery that can be a corridor for natural ecosystems and little flora and fauna that could be living within the city, but it also allows for air to move through the city and help keep the city cool. So actually planting along the buildings, that again, that could make sense. It could provide shade for the building, it could keep it cool, it could keep the electricity costs down, all of that thing down. Maybe you could even use it as a gray water system. So using it to maybe use gray water, recycle it, I'm not quite sure. Asterisks, as long as it's indigenous vegetation. As long as it's not alien vegetation that's brought in, if that is vegetation that would naturally be growing in that space, then it makes sense. Otherwise, you need to add more resources and effort like water or whatever else to keep these plants alive, and that wouldn't really then contribute to the balancing of the ecosystems in that area. So if you're growing vegetations that naturally grows there, then it makes sense. Then it could be self-sustaining. Then the seasonal rainfall that it does get would make sense. I want to take a look at some South African cities. Obviously, we always have to bring it back to South Africa. Oh, this is just what some places are doing. I think this is in the States. Yeah, in the United States. Some things that they're doing to try and combat the urban heat island. So increasing vegetation, creating green roofs, install cool roofs. I actually don't know what that is. I'm curious. Let's take a look. Oh, it's more reflective. So it's more shiny and more reflective. So that adds to the first point, the lightening surfaces. This one, making surfaces lighter. So that must be the cool roof. Cool roof is cool. So I wanted to look at Cape Town and Johannesburg in terms of how they are responding to the urban heat island effect. So obviously, because of following the South African curriculum, I want to always bring it back to some South African case studies. And what makes it so interesting for us as well is that we're not a very wealthy country. So we can't just build roof gardens everywhere and redesign our entire city. We have to work within our means, but that also means that our South African cities are very hard hit with something like this. So here you can see, so this is your heat map. Here you can see all of the hot areas. There's the city center, very warm. Okay, that's about as clear as I can get the image. But you can at least still see the color difference. So you can see all of this red over here and a little bit of a lighter blue towards the south. Could you have any guess why? So it doesn't have a very typical island shape. You can't really see the cool surrounding areas in the hot middle. So you can definitely see the heat, the peak over there towards the city center. But it doesn't have that typical island shape. And the reason for this would be because of the way the wind blows. The wind often blows inland from the south. Okay, so, and over here, it would often blow away. If it does come from this side of the coast, it would be blocked by the mountain. So you don't have that strong wind blowing in and clearing all of this away. Where you do have that, where you do occasionally have the strong wind blowing in, blowing all of the smog and the air pollutants away, we refer to that as the Cape Doctor. So it's the fresh breeze that blows all the pollutants away and keeps the air clean. Okay, but that was besides the point. Then I think Joburg also had a good map. Let me just find theirs. This is the one I was looking for. So daytime urban heat island and nighttime urban heat island. What's nice about this is that you can actually see that point that I was making about how during the day the air is rising and the cool air is blowing in. So at nighttime, you can see the bigger range. It goes down from 1 degree. Or is this degrees or index? Oh, it's an index, sorry, not degrees. But from 1 to 6 and from 0 to 1.4. So it's definitely more extreme during the nighttime than daytime. But again, you can see this clear difference in temperature. And the reason why it's quite a concern for cities, especially South African cities that are quite poor, is we don't have the means to make it comfortable for all of our citizens. It'll be easy for a lot of people to say just go indoors and turn the aircon off on those very hot days. But the areas where the urban heat island is most extreme are the areas that are most built up and have the least amount of vegetation. Where you'd expect to see that are the poorest parts of the city. So you tend to see where you have your suburban areas or your more wealthy areas, you typically have big gardens, lots of parks, lots of space, and you don't see this extreme or as extreme heat island effect. So where you have these extreme islands, you probably also have the poorest or most disadvantaged communities. And when I'm talking about poor areas, I'm not just talking about your densely built up concrete jungle. I'm talking about informal settlements. So I'll be honest and say I don't know which areas, what these 4 areas are. Maybe, are these coordinates? I think so. I think they might be coordinates. We can go check in a minute, but I'm suspecting that these are probably some types of townships or informal settlements. And that's exactly what this article was also busy discussing, is how it's these really poor communities that are the hardest hit. And they are the ones that don't have the ability to do anything about it, but they're still the most affected. And when we're talking about extreme heat, we're talking about severe heat stress. You basically have people building their homes out of literally anything that is available there. And most frequently, the material that's available is some type of metal sheets. So I think it goes without saying that these areas that are the most vulnerable and most hard hit are the ones that are sitting in these little tin cans of houses and sitting in these sweltering extreme conditions. So that is why something like the urban heat island effect is a very real concern for cities in South Africa. The people are experiencing it to a degree that we wouldn't normally think about. But there are a lot of movements in place, a lot of projects. So I found this over here. Joburg facing heat island effect. Okay, just explaining the whole concept. They're explaining what it is. Here, he notes that people living in informal settlements are more susceptible to the heat island effect because they do not have windows, air conditioning, or access to tap water in their homes, which means that they do not have the adaptable capacity to withstand the increased heat and cool themselves down. So that's why, unfortunately, these climate effects are very real for these communities. I can't find what they are doing. They say over here residents are taking steps to reduce their own contribution to the heat island effect by choosing energy efficient appliances and reducing their use of air conditioning and single use plastic. I don't feel like that's a good enough answer. I'm sorry, they need to say a bit more about what they're doing. I know that there is extensive research being done into it. A lot of it is community-based research, like that article that we saw. This one, Citizen Science Project maps heat stress in Johannesburg. So there is movement being done towards actually addressing it, and that's at least a start, but it's really not much of an answer just yet. So we can see that there is a lot that can be done in terms of lightening surfaces, greening, planning for this in the future. But I would like to see a little bit more from our South African friends to see what is happening. I hope that you guys learned something. I hope that you found this interesting. Have a lovely day. See you again. Be good. Cheers. Bye.